Greetings, Algebra 2 students. Today we're going to be talking about solving inequalities. And as a warm-up, we're going to take a look at the two ideas of inequalities versus positive and negative numbers. As you think of these numbers, one of the ways you can consider them is where they are on the number line. We have the number 6 and we have the number 12. Obviously 6 is smaller than 12, and so that is the sign, hopefully you remember, less than. So, in summary, is this true or false? It is definitely true. Our second problem, we have negative 12 here, negative 6 here. Negative 12 is further to the left, so negative 6 is not less, it actually is greater. So this is false. As we consider this, we want to think about what does it really mean to have the inequality x is greater or x is less than 6. In this case, x is less than 6. What are the values for x that makes this statement true? This is a great chance to consider all the different sets of numbers that we had. The smallest set, remember, is called the natural numbers, followed by the wholes, followed by the integers, followed by the rationals, followed by the real numbers. And on the other side, we have the irrationals, followed by the real numbers. And if you remember our sets of numbers, one led to the next in terms of a funnel kind of a concept. So anything on the number line is a real number. And so this would be all real numbers less than 6, but not equal to. Okay, so that would be the things that would help us to get started on this. Let's take a look now as we graph our solutions on a number line. Well, we're going to put an open circle around 6, and we're going to shade everything to the left. So it might be easier here in this case to use your highlighter, nice and quick, for a quick shading. In terms of our vocabulary, a solution of the inequality is the number or set of numbers that makes the inequality true. It might be one simple number or it might be a set of numbers. So, as we talk about solving our inequalities, we're going to have to try to think about some things. We're going to distribute here first. So 8x minus 40 is greater than or equal to negative 16. We're going to add 40 to both sides. That gives us 8x is greater than or equal to 24. We're going to divide both sides by 8. That gives us x is greater than or equal to 3. Now let's graph this and come over to the number line. We're going to put a closed circle at 3 because it's not only greater than, it's also equal to it. And then we're going to shade using my highlighter to the right. Now, I put a bubble down here, and remember, anytime I put a bubble on our problems, that generally means that this is something that you are really going to have to pay attention to, because it's got very significant implications down the line, and it could be a factor as we're going to it. So, when solving an inequality, in order to graph, the variable needs to be on the left. And notice here the variable is on the left. That way, you shade in the direction of the inequality. Notice the inequality right there, it's pointing left, so you shade left. Now, this only works, though, if the variable is on the left. Okay, let's keep moving here. Our next one, we're going to solve the inequality. So once again, we're going to distribute first. Distributing less than 3x minus 15. I'm going to subtract 3x from both sides. Most of you are very comfortable with this. Negative 5x is less than negative 15. In this case, now I divide both sides by a negative 5. And I need you to circle this right here. Hopefully you remember at this point there's something very important that happens when you divide by a negative. And hopefully what you realize is dividing by a negative simply means you change the inequality from greater than to greater than from less than. So my answer is x is greater than 3. We come over here and we're going to graph this, open circle on 3, and we're going to shade everything to the right. Remember, an open circle means you go up to the number, but we don't include that number. So I put this as an important note here. Remember, what must you do when you divide or multiply? Need to put or multiply there. Divide or multiply by a negative. Very simply, you change the sign. Okay? You change the inequality to the opposite. All right, example 3. Michael and his 2 friends. Okay, so let's take total 3 people. Just a quick little side note. Have exactly $35 to spend on lunch. Hot dogs cost $3.50 and drinks cost $1.50. So they each get 2 hot dogs. How many drinks can they buy? The question is, how many drinks? That's the question. On story problems, you need to focus. Second, how many drinks leads to what variable are we going to use? I want to use a variable that relates to drinks. What variable am I going to use? Let's not use X. Let's use something that relates. So let's use D, and let's have that equal the number of drinks. When you do problems like this and you create a variable, we need to use what's called a let statement. We need to define what our variable is. So here we go. Michael and his 2 friends have $35 to spend. They can't spend more than $35, so everything they have must be less than or equal to $35. They each get 2 hot dogs. So 3 people times 2 hot dogs each, that's 6 hot dogs times $3.50 plus $1.50 each for the drinks. Well, 6 times $3.50, well, let's do this in our heads again. 6 times 3 is 18. 6 times 50 cents is $3. So we add 18 and $53 and we get $21. We're going to subtract that $21 away from both sides. That leaves us with $1.50D is less than or equal to 14. Now we're going to divide both sides by $1.50. So you can do this in your head if you wanted to. You'd have to divide by 1.5. All right, if you can't do that in your head, then take out your calculator and divide 14 by 1.5. You're going to get 9.3 repeating. 9.3 repeating. Can't really buy a third of a drink. So how many drinks can they buy? They can buy 9 drinks. So let's make sure we answer the question. 9 drinks. Pretty simple, pretty straightforward. Up until now, all of our inequalities have worked out nice and neatly. All right, what's going to happen if the variables cancel out? We've got 2 different scenarios. No variables, and we end up with a false statement like, is 3 less than 1? If that happens, then the answer is no solution. All right, that means nothing is shaded on the number line, nothing is dotted on the number line, and you're going to have either an empty number line as an answer, completely empty, or you're going to have to put the symbol no solution. If, on the other hand, you drop out your variables and you end up with a true statement, like -4 is greater than 10, well, that would be a mistype. Let's correct that right now. -4 is less than 10. That's a true statement. Okay? If that's the case, that means all real numbers work. And that's our answer. Remember to write all real numbers. You kind of do a cursive R with a double line. And what that looks like on a number line, very simply, you're going to take the whole number line and shade the whole thing. I apologize for that mistype there, but obviously that is not correct as we're looking at that middle part there. So we need to make sure we cross that out completely and look at it, consider an inequality that would be a true statement. All right, let's look at example 4 then and see if one of these 2 situations come up. Our first one, we're going to distribute the 7. That gets us 14 plus 7x. I hope you see you subtract 7x from both sides. You end up getting 0 is greater than or equal to 14. True or false? That is a false statement. So what is my answer? An empty number line or no solution. All right? You would just draw an empty number line, or you could write no solution. If you want, you can physically write the words no solution. In order to do this, you need to come over here and show why it's false. Let's look at example 5. We're going to distribute the 6 on the right, so 6x minus 12. We're going to subtract 6x from both sides. That leaves us with negative 13 is less than negative 12. Is negative 13 less than negative 12? Yes, it is. When? All the time. Okay? Sometimes I think about this as God is good. Yeah, all the time. So that is all the time true. It's not true part of the time. It's true all the time. God is good all the time. So what is my answer? All real numbers. Let's remember the symbol for that, a cursive R with a little curly and a second little line. And how do I do this? Very simply, I shade my entire number line. Okay, so let's just shade that entire number line with an arrow at both ends, meaning it goes either way. So you have 3 different ways to consider this: a number line, words, or the actual symbol. Let's keep moving here. Here we have solving the inequality. I've thrown some numbers in there with some distributing. So 4x minus 12 plus 7 greater than or equal to 4x plus 1. I subtract the 4x from both sides. I combine my 12 and 7 to get negative 5. Pause for a second. Think to yourself. Negative 5 greater than or equal to 1. True or false? Hopefully you're saying that's obviously true. So what is my answer? All real numbers. So let's use the symbol here with that double line, cursive R with a little tail on it, reminder. How do I shade this? Reminder, all real numbers. Yes, that's the entire number line shaded. So we've got kind of a consideration here of some different things. Let's kind of review very quickly. First of all, true statements versus false statements. Defining on a number line, it really means all real numbers. How do we do that? Open circles and closed circles. Here's a closed circle. Remember, if the variable is on the left, you point left and you shade left. Next, if we divide by a negative, we change the sign. Very important there. Problem solving, remembering, define your variable, create an inequality that represents your situation. Try to figure out what is your question. And then look for simple little things in the problem like, hey, how many people do we really have? Oh, we really have 3 people. Okay? And then down here, the 2 possible scenarios that could come up. Either no solution when it's false, or all real numbers when it's true. How do we graph those? Either leave a number line blank, symbol, or words, or completely fill in a number line, or write all real numbers, or use the symbol, the cursive R with the double line on it and the curly tail coming down. So, hopefully that's a good situation for solving inequalities. Our homework here, we're going to hit section 1.4a, page 29, 1 through 15 all, 63 through 69 odd. Okay, let's remember a couple simple things about doing homework. We have got to remember, show your work completely. Also, let's work in 2 columns, copy the problem, work down, circle your answer, and skip a line. And please also remember, top left-hand corner, let's put the section number. Top right-hand corner, put your full name.